Hello, my name is Shahgadkar and I am from E&TC. Today I will be giving my presentation on the topic data analytics and I will be answering these following questions, which is question number one, pandas in data analysis. I will be explaining what pandas are in data analysis. In question number two, I will be telling you about or I will be sharing my knowledge about importing and exporting data from Python using pandas and I will be analyzing the data for different basic operations. In question number three, I will be answering the question that what is the difference between data mining and data profiling. In question number four, I have been given a problem statement in which I have to go through this particular string. COVID-19 cases, corona cases are increasing at faster rate and I have to check that each and every word of that given string is even or the length of the word in a particular string is even. If it is even, then I have to print even, and if it is odd, I have to print a space. Now let's move on to the question number one. So let us continue with the question: what are pandas, or what are pandas in Python? So pandas is an open source library, Python library, which provides us with high performance data manipulation and analysis tools using powerful data structures. So the word Panda comes from a set of words known as panel data, which is econometrics from multidimensional data. And what multidimensional data means is what I will be explaining in the further. But for that to understand, we need to look at the topic of the data structures in pandas, which are series and data frames. So now in series, what are series is that it is a one-dimensional array-like object. So what does this mean is whenever you input or whenever you initialize an array in a given programming language, may it be Python, in C, in C++, in Java, any programming language, when you initialize array, what it is a set of data, which is a it is a fixed sized streamlined set of data and its index numbers are not visible to us on the output window or on the screen. So in series, what happens is that whenever you initialize a data set or whenever you initialize a particular dictionary as series or a single line, what it does is whenever we print it, it gives the index number starting from 0 on the left hand side and it gives the value which is assigned to that index number on the right hand side. So the index number by default starts from 0 and ends till n minus 1. So what n minus 1 means is that n is the length of the particular data set which I have given or the length of the particular dictionary which I have initialized as series using pandas. So why n minus 1? Because our indexing starts from 0 and not from 1. So we are considering it to start at 0 and ending at n minus 1. So let us see, let us look at some examples. So in this first example, what I will be doing is just copy paste. Okay. Okay. So in this first example, what I did was I imported pandas as PD. So I imported the open source library pandas into my Jupyter notebook, into my Python environment, virtual environment as PD. And from pandas, I imported series and data frames, which I will be explaining further. So now what I did is we created a variable or initialized a variable obj and I set it as pd dot series. Now I gave it a data set or a series. I initialized the series which is integer numbers, four integer numbers. And like I said, on the left hand side I got all the index numbers and on the right hand side I got the values which are assigned to those index numbers. So by default I did not give any index numbers which I wanted. So I by default got from 0 to n minus 1. And why n minus 1 is because my series is of four values, which is 1, 2, 3, 4. So my length is 4. But as I said earlier, the indexing ends at n minus 4. So that is 4 minus 1, which is 3. So now if I not initialize now, if I write it as obj.values and if I run it, so what it does it, I can use labels in the index when selecting single value or a set of values. So what I did is that I used labels as values. So what this label gives me is it provides me with an array of the given values. So now let me say I don't want values, I want index numbers. So I'm providing it with the label obj.index. It will only give me the range of index from where it starts, where it stops, and how much steps it has taken. Now what the start means is that it starts from 0. What the stops mean is actually it does not consider the index number 4, but it stops before the index number 4, so it is giving me stop is equal to 4, and step is 1 means the difference between these indexings or this index numbers is 1. Now moving further, so it is generally recommended to give index numbers as per your own likings or as per your own wish, because whenever you're going through a particular data set or a particular series of data, you need to know what its serial number is. So let's say you're working at a company and you have to maintain a data set of a warehouse. So go you don't go and tell the program or tell the particular Python code to give the indexing themselves. So you know what the serial number is. So you want to give the indexing. So it is generally recommended to give the indexes or the indices as per your own wish, like I have done here. So what I did is I initialized or I wrote a code to initialize a series which is the same as 4, 7, minus 5 and 3, and I gave the indexes as D, B, A, and C. When I give this particular line of code, this particular index D is mapped or it is shown a path that U will contain a value which is 4. Then B will contain a value which is 7. A will contain a value which is minus 5. C will contain a value which is 3. So it maps, this index maps its given value, which is 4. So I'm getting a output as D 4, B 7, A minus 5, C 3. Now, when I run this particular line of code, I get minus 5. So just as whenever I declare an array or whenever you declare an array and you want a particular number or a particular data or a particular value which is present at that per given index number, you you usually use this method in which you use a label or use a index number, a particular index number to fetch a single value or a set of values. So here when I used index as a label, I fetched a set of values, or when I used values, I fetched a set of values in a given particular data set or data series. But when I'm using only A, what it does is it looks into this particular line of code and it understands that okay, so you want the value which is present at index number or the index A. So okay, he has given me the value which is present at index number A. The same way, if I give this particular code, so what happens here is I am telling the program or I'm telling the Panda library that my object 2 which I have created, which is 4, 7, minus 5 and 3, I want the value which is at D, that is 4, to be replaced with the value 6. So it did exactly as I asked. It replaced the value which is present at index D to 6. And I asked it to only print the values which are present at C, A, and D. And it did exactly the same. It printed only the values which are present at index C, A, and D. So now when I run this line of code, so these are basic arithmetic or logical functions which we can give to the particular series. And actually, the Panda library or the Pandas is comfortable working with such mathematical or logical expressions. As in, now I gave this particular line of code in which I told that I want to print all the values in my object dataset or object series which are greater than 0. So from from the beginning, I have given the series object 2 as 4, 7, minus 5, and 3. Now, when I give this command or this particular line of code, it checks my object 2. It checks the index number and it checks the value which is present at the index number. And if the value of that index number is that index is greater than 0, then it prints the given output, that is D is 6, B is 7, C is 3. It does not print A because A is less than 0. Now this was the example which I showed you for logical expression. Now this will be a mathematical expression which is obj2 star 2. What it does is it multiplies the values which is present in that given data set into 2. So D is 6, so it will give me 12. B is 7, it will give me 40. C is 3, it gives me 6. And A is minus 5, which gives me minus 10. Now, when I run this, when I paste this and I run this particular code, so what it does is it checks if this particular index number, which is B, is present in the data set or a particular series which I've initialized object to. So yes, the index number B is present. So it gives me a boolean value or a boolean output which is true. So now if I check that E is present in option object 2 or not, and if I run this particular code, it gives me false because index E is not present in my given data set or my given series. So let me initialize this particular code. Let me initialize this particular series. Now what I'm doing is that I am giving it a, or I am initializing, or I am inputting a dictionary in which I'm giving the index as Ohio and the its value as 35,000, Texas 71,000, Oregon 16,000, Utah as 5,000, and I am telling that this S data which I have provided, or this S data dictionary, I want it to be printed as series in object 3. So now what I did is I printed this particular object 3 and it gave me a series with indexes as Ohio, Texas, Oregon, Utah, and the values and the following. So in this, what we get to know is it is not always necessary to give the particular index as I mentioned here. That's the first the values and then the indexes. Which in here we can easily give a particular value to assign a particular value to a given index number by using this method that we provide its index number first and the value which it belongs to second. So now when I run this particular code, what it does is that what I'm doing is I'm taking a variable to initialize the dictionary states in which I'm giving California, Ohio, Oregon, and Texas. So now to begin with, I'm not giving any value or any input to the index number California here. So what I did in the second line is I initialized the object 4 and I said that I want a series in which my S data and index, I want all the values from my S data, which means from this line, from this initialized line, I want all the values from here and I want the indexes to be as the states or this particular data set which I have given or the index set I have given here. So what will it do is it will check all the indexes and it will check the S data values. So what it does is it will check California. So if California is present in this S data, it will give me a particular value. But in this, California is not present in my S data and I have not initialized any value. So it gives me NaN, which means not available value, or there is no value available, not no assigned value. But when I check Ohio, Oregon, or Texas, it recognizes that Ohio, I gave a particular value to that particular index, in S data as 35,000. So it prints 35,000. In Oregon, I give 16,000. In Texas, I give 71,000. The interesting part of this is I can run this particular line of code and it tells me that pd dot is null obj4. So what this means is I am checking that if my indexes which I've provided in my object number 4, the indexes I've provided in my object number 4 have or do they contain a value. So is null is basically asking ki tell me which all index number does not contain a value in my given data set which is initialized as object number 4. So here in California there is no data or no value available here because I haven't initialized this particular index with any value. So it gives me true because yes, California index is null, so true. But Ohio, Oregon, and Texas are not true. So basically, it gives me false because it is telling me that yes, they contain a particular value. But now, if I print this code that and I ask it that if pd dot not null object 4, so tell me which all uh, basically I'm asking this that I want you to tell me with a boolean output that which all values are not null and which is null. So this is exactly opposite of this because here I'm asking to tell me which is null and here I'm asking which is not null, which contains a value and which does not contains a value. So when I give this particular line of code, what it does is it checks California, the index California, and does it has any value? No. So it is not null. So it gives me false because the index California does not contain any value or does not contain any data. So it is giving me false because it is not null. And when I check Ohio, Oregon, and Texas, it is giving me true because Ohio, the index Ohio contains a particular value which I initialized here in object number 4 states. So Ohio, Oregon, and Texas, it gives me true because they are not null. So this condition is satisfied. The same as this condition in this out. Now, what I did here is I can either give this as uh, what we can say is okay. So I can either give this as an attribute or as a object, or I can give this as an okay. I can give this particular thing as a label or as an attribute. So what I'm doing here is I am giving it as a label. So I want pd dot not null of object 4, so I'm giving it a label object 4, and here I'm giving it an attribute which is object 4 dot is null, and it gives me this return out. So now after what I've explained in series, now let us move on to this particular operation, that is mathematic or arithmetic operation. So the most interesting part about this is that the index which I have given in object number 3 and which I have given in object number 4. So there are three indexes which are the same in object number 3 and object number 4. So what it does is it checks if index California is present in object number 3 and is present in object number 4. So in object number 3, California is not present, but it is present in object number 4 and it has not been assigned any value. So it gives me NaN. But Ohio, Oregon, and Texas are present in both of these objects or both of these data sets. What it does is it adds up the values which are present at that particular index, which is Ohio. So in my object 3 on my data set, which I initialized in object 3, my Ohio first value was 35,000. And in the second one, I provided it with the same values as data, so it was 35,000. So it gives me the output as 70,000. Same as Oregon 32,000, Texas as 1,42,000. And when I check this Utah, in object number 3, I have initialized Utah to be 5,000, but I don't have any object or any index given as Utah in object number 4, so it gives me not assigned value. So this interesting part of code is when I run this particular code, what it gives me is now I am giving this particular object or this particular data set or a series a name which is population. So I initialized this particular series and gave it a name population, and it gives me its data type which is float, and I named the index that I want, that is I named this index row as state. So now whenever I want to call those particular indexes, I can simply say call it under the name states, or I want this particular data set known as population. So I don't have to go on initializing these all numbers time and time again. So now let me do this. Okay. So the first line which I initialized for the series was object, and I gave the series as 4, 7, minus 5 and 3. And there I have received the indexes as 0, 1, 2 and 3. So here in this particular code or in series or using pandas in Python, it is possible to alter the indexes as per a user's wish or as per a programmer's wish at any given point of time. So I do is object.index is equal to Bob, Steve, Jeff, Brian, and if I run it, okay, I need to call this again. Object. Okay. So if I run it, it gives me the indexes as Bob, Steve, Jeff, and Ryan instead of 0, 1, 2, 3 because I here initialized this particular object with the indexes as Bob, Steve, Jeff, and Ryan. Now let's get back to presentation and see what data frames are. So data frame is basically it represents a rectangular table of data, meaning that it has rows and columns both. It is not a singular or one-dimensional group of data. It is not a type of array, but it is a multi-dimensional array. So it contains both rows and columns. Excuse me. And these rows and columns can be of different value types. So it can be float, it can be character, it can be integer, it can be any different value. This data frames can be thought of as what we can say, it can be thought of as a series all holding the same index. So what that means is that when a series of data is initialized or when a rows and columns is given, so this particular row has a set of datas in a column. So if I take row number one, so row number one has a series of data. Row number two has a series of data again. Row number three, row number four. So this means that it can be thought of as a dictionary of series all sharing the same indexes. Now let us look at some programs. So what I do here is to call this. Okay, so what I meant by a series of data which is in a rectangular table form is that I initialized a data set or data frame by giving it a name data. I gave the index or the column to be named as state, the first column to be named as state, the second column to be named as year, the third column to be named as pop, and I gave these particular indexes or the column indexes the values as Ohio, Ohio, Nevada, 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 in 2000, 2001, 2002, again 2001, then pop as that is short form for population as these particular numbers. So uh, what it did is it gave me a rectangular representation of this data set, particular data set. So at index number 0, as I said, that it can be seen as a set of series sharing the same indexes is on the index 0, these particular series of data, that is Ohio 2000 and 1.5, is sharing the same index number. Same goes for index number 1, 2, 3, 4, 5. So there are many ways to construct a data frame, but the most common is from a dictionary of equal length list of numpy arrays. Means just as I have given here that I have given equal lengths of arrays, which is numpy arrays, normal arrays, number arrays. So what I did is I gave state, I initialized state, and I gave it as an array like equal length. So it is 6. Here I gave 6 inputs, pop I gave 6 inputs. So this is the most common way to initialize the data frame, because when I give all these 6 inputs, there is no need to write anywhere NaN, or no need for the computer or this program to run its own screen and give the input as NaN, because I have already given it the input as equal lengths. What this frame dot head does is it this particular function frame dot head gives me only the first 5 data inputs, or give me only the first 5 data sets from the given data frame. So basically for large data frames the head method only selects the first 5 rows. So as you can see here that from 0 to 4, these are the 5 rows which have been printed here. So if now I have say a data set or a data frame consisting of 10 rows or 100 rows, and you want only the first 5 rows to be displayed, so you don't go initializing or telling the program to give me the output of all the 100 data inputs which I have given. So what you use is you use frame.head and you give open close bracket, in which it will by default give you only the first 5. So now what if I did this and if I give only 2, if I run? So in this what will it do is it will only give me the output or the data which is present only on the first 2 rows. So these 2 rows it will be giving me an out. The same can be done as for 1, for 2, 3, 4, and the number which you desire. Okay, so this line of code, what I did is if a column, uh, okay, so if I'm giving columns in a particular order, like I gave here as state, year, and pop, this particular sequence of columns can be altered anytime using this particular syntax, which is pd data frame data comma columns, in which I'm calling this particular data frames. This here pd node data frame, I want to create a data frame, so I'm creating a data frame in which I'm taking inputs from this data, and I am telling that change the sequence of columns from state year pop to year state and pop. So this particular sequence can be altered anytime. And when I alter this particular sequence of year, state, and pop, it not only changes the indexes present for this particular numbers in that particular column, it also switches the places for these values. So under the year, like here, if I change the year, it will also switch places with all these values. So now when I run this particular code, which is I created a frame2 variable as a data frame in which I gave the inputs the same as data, and I gave its column as year, state, pop, and date. So what happens here is, and I changed the index number from 0, 1, 2, 3, 4 to 1, 2, 3, 4, 5, 6. So whenever I initialize or whenever I input a column which I have not initialized, it by default gives me all the values as NaN, that is non-accessible numbers or non-assigned numericals, non-assigned values. So I did not assign any value for this particular index of the column then. So it gives an empty column with the output as NaN, no assigned value. Now, what this, okay, so as we saw in the first series, is that when I call this particular function or this particular label, I have to call either frame2 dot values or frame2 dot index to get either index numbers or either the values present at that index number. But since this is a rectangular form or a two-dimensional, which has rows and columns, so if I give this frame2 dot columns, it gives me the indexes which is present at those particular columns. So this column has indexes as year, state, pop, and depth. So it is giving me the output as year, state, pop, and depth, which are the indexes for these particular given values. The same, if I want a set of values from a particular, say I want a set of values, that is I want the values which are present at state, only those values which are present at state, then I can give the label as frame2 into bracket state, the same as I gave the input to the series that I want the variable or I want the value present at index a. So what I'm doing is that I want all the values present in the column which is labeled or which has the index state. So the values which is present in the index state in that particular column is Ohio, 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 Nevada, Nevada, Nevada. So I am getting these values. Now if I do frame2 dot here, it will give me all the values present in the column here. Now what I'm doing here is, now if there comes a scenario that in a particular data set which you have initialized or a data frame or a dictionary or a set of data, rectangular data which has rows and columns, you have initialized and you have certain column which has not yet been given any values, and then you realize that all the values for this particular column should be same. So what I did here is I called this particular depth column with the index as depth, and I assigned all the values in that column as 16.5. So then what happens is this particular column at index depth is being given the value 16.5 from 1 to 6. Okay, so now if I do this particular code, if I execute this particular code, what happens is that I told it that let me initialize that particular series as val, and I want this particular values to be on the index number 2, 4, and 5. So at index number 2, 4, and 5, I want these particular values to be inputted. And where on which column do I want it is I said that in this particular data frame 2, I want it to be displayed on the depth column. So what it does is on the depth column, it checks the index number 2. So when it comes to the frame number 2, in the frame number 2, I did not initialize depth. So I created a frame 2 data frame, but I did not initialize any value to this depth. So it gave me all NaN values, right? So what happened here is I said I want these particular values to be given at index number 2, 4, and 5 of the column with the index depth. So what happened here is it initialized the index number of the row 2 and the column index of column depth as 1.2. The same goes for 4 and the same goes for 5. So in this, what I did is I said that I want a separate column with index Eastern. Now, and I said that I want to check that if in the state column or in the column which has the index as state, if the values at this particular column's index state is Ohio, I want this Eastern to be given as true, and if it is not, then it will by default give me false because it is giving me a boolean value. I asked it for a boolean. So here what it did is it checked every value which is present in the column with the index state, and wherever there is Ohio it gave me true, and wherever there is anything else but Ohio it gave me false. Okay, so now moving on to the next part of this code is the delete function or the del function. So what it does is that here, as you can see, I gave this frame number 2 the extra column as Eastern, which I initially did not assign any value to it. I just asked it that if the state column has Ohio value in it or the Ohio data in it, you need to print true. I did not assign it any value. So what I can do here is I can delete that particular column by using del function. Now del frame 2, so I want to delete this particular column from frame 2, and now I printed out the columns which are present in frame 2. Now here, as you can see, there is not a single mention of this particular column Eastern which was present here. Now what this does is I said pop is equal to Nevada, and I gave these particular indexes. I want 2001 to be index of this particular column, and I want the values to be 2.4, and at 2002 I want the values to be 2.9. The same I did with Ohio. I want the index number to be 2000. I want the value to be 1.5, and index number 2001 I want 1.7, and 2002 I want 3.6. So what it did here is, so in this particular function what happened is this is a nested dictionary of dictionaries. What I did here is I created a particular series or a dictionary in Nevada in which I gave its index to be 2001, and the index or the value for the column Nevada I gave it as 2.4. So this is basically what we say a nested dictionary of dictionaries. Now when I run this, it gives me frame3.index name. So what happened is it gave this particular index as a name. So this is basically x-axis and y-axis. So if I had to plot a graph about this, then the graph which is present or the values which are present at y-axis will be given the name year, and the values which are present at x-axis will be given the name state or the topic or the heading name as state. So what it did is it named this particular column. So this particular column is called states and this particular row is called year. And as I mentioned earlier, it gives me in series what we saw was when I called a particular value or when I called values which were present in the given series, it gave me only a single or a sequence of array. But here what it did is it gave me a multi-dimensional array. So what it means is that whenever I call a certain values or whenever I call values from a data frame, it gives me a multi-dimensional array. That is rows and columns, the values present on that particular row and the values present at the particular column. So as with series, the value attributes returns the data contained in the data frame as two-dimensional ND array. So now if so okay, let's say if the data frame columns are different data types, the data types of values in that array will be chosen to accommodate all the columns. So what that means is let's say I want all the values from frame number 2. So now in my frame number 2, what I did was I initialized this frame number 2 to be year, state, pop, date, and everything. So now what it did is when I called frame 2 dot values, irrespective of what the data type is, it gave me a multi-dimensional array. So the data type here was 2000, which is integer. The data type here is character. Data type here is float. Data type here is no assigned value. But still, it gave me a multi-dimensional array. So what it did is it gave me a rectangular table or a row and column type table of the particular values which are present in frame number 2. So now moving to the next topic, which is index objects. So what are index objects is that they are responsible for holding access labels and other metadata like access names or access name. So what that meant is now if I am giving a particular data frame, so it consists of rows and columns, or if I want to print a particular graph in which I want the rows to be on the y-axis and if I want the columns to be on the x-axis, then I need particular names or the axis names for that. So what I did here is basically what explains these index objects. So here I gave this particular index, that frame 3 index name is year and frame 3 column name as state. So what it did is it gave this particular x-axis the name state and this particular y-axis the name year. And these index objects are immutable. That is it. That means that they cannot be changed by the user. They cannot be altered or played with by the user. What I meant by that is, let me show you a code about that. So now let me print this particular object which I gave as which was the first object. So now what I did is the first object I altered and I gave its index as Bob, Steve, Jeff, and Ryan. So I called this index once again, and now I will be printing this. So what it did is that it skipped this first one. So it skipped this first index and it gave me the rest of the indexes which are present in this particular data set. Now when I run this particular code, what it gives me is it gives me a type error, which is type error is index does not support mutable operations. Like I said in this particular point that this particular object, the index objects are immutable, so I cannot change the values which is present and at this particular index. So I basically told it that I want the value at index number 1 to be changed to D, but it said that I cannot do that because this particular bob or this particular index which I initialized here already has the index D. So basically, in addition to being array-like, these indexes are also what we can say. These indexes are fixed sized sets. So what I mean by this sentence is, if I call this particular line of code, so these sizes are fixed in this particular column. So now frame 3, if I check this frame 3 which I initialized here, okay, if I check this frame 3 which I initialized here, I gave Ohio and Nevada as these particular inputs. So it, even though there are two or three inputs which I provided for this particular columns, these are fixed size. These size cannot be altered unless and until I give an extra row for that particular frame. So now, okay, so this particular line tells that unlike normal uh, Python or normal Python sets, a Panda index can have duplicate labels. So what I mean by this is, when I in normal Python, if I give two same labels for a particular thing, for a particular data set, it gives me as an error because it says that this label already exists. Why are you trying to initialize or compare or assign a value to it again once again? So unlike normal Python sets, in pandas it allows me to use duplicate labels also. So now, as I have, so now I've covered all these inject objects. So let's move on to question number 2. Okay, so moving on to the next question, I will be showing you how to import and export data from Python using pandas. So let's see what I've done here. In this folder in which my Python is already installed, I created a test Excel file. Now what I need to do is I will save this file, let's say in this particular folder, as CSV file. So yes, I will save this particular. Uh, so I will save this particular data set or this data file which I've created as an Excel in my Python folder. So now, if I need to import this into my Python program using pandas, what I will do is I will say import pandas as PD, and this particular simple function that I have to give is, let's say, PD dot read underscore CSV, and the name of the file, that is test.csv. Okay, so as you can see here, when I wrote this pd.read csv, so what I told this particular program that I want to import this particular library panda, and I want to read this csv file which is present in my Python folder. So when it read this file, it gave me the output as ABC and 1, 2, 3, 4, 5, 6. So by default, I did not provide any index number to that CSV file. So it gave me 0 and 1. So now what I want to do is I want to import, I just read this particular file from the directory. Now I want to import it in my Python program. So what I will do is I will say df is equal to pd dot read underscore csv and say test dot csv, and then I will call this particular df, and let's say I will call it once again. So basically what I did here is I initialized a particular variable and said a particular data set or a data frame. Df stands for data frame. So I initialized this particular data frame and said that I want all the contents that are present in my test.csv file to be the contents of my df, that is data frame. So whenever I call this df, I will get this data frame as the same data set which I initialized in my Excel sheet. So now I did import this. So now what if I want to export this particular file? Okay, so now what I have to do is I have to show how to export this particular test.csv file into say another CSV file, or this particular data frame which I have created here into another data frame which is present in an Excel file. So what I will do is I will say that this particular data frame which I have, or these values of the data frame, I want them to be returned to a CSV file whose name is say test complete.csv file, and I don't want it to give me any index number. What I did is I said that I want my this particular data frame to be converted into a CSV file whose name is testcomplete.csv, and I don't want that CSV file to contain this 0 and 1 index number. So I said that index is equal to false. And if I run this particular line, and if I go and check in my Python folder, here I can see test complete CSV file. So when I open this, these contents are present in my test complete CSV file. So the basic operations that we performed in this particular code was that I read the particular data, I created a data frame for exporting, I provided the path. The path means that there's this particular path. So what I did here is that if you want to read a particular file in your Python folder, I highly recommend, or it is highly recommended, that you open the folder in which that particular file is present, click on this particular path bar, and then write here cmd and open the command prompt. When you open that command prompt, just open the Jupyter notebook, and you're good to go with just writing the file name as say test.csv. But say if you're not opening this particular you're not opening your Jupyter notebook using this given path. Say you're opening it directly from the desktop using search menu as CMD. So what you need to do is that you need to copy this whole path, give backslash, and then give the name of the particular file which you want to read or which you want to import in the particular program. Then what we did is we saw that the data is stored in the form of commas, that is comma separated values. That in the previous examples we saw while giving some some inputs in a series, we separated the values by using commas. Now we saw that we gave these particular values as CSV. Now moving on to the third question, which is the difference between data mining and data profiling. So what is data mining is that it is basically identifying patterns and correlating with large data sets. So what that means is it's just like mining. So we identify that on which part of land a particular mineral is found, and then what we do is we relate those datas for say a large deposit of coal. So what we say, if there are five coal deposits in a particular area, so there is likely to be a one larger um, coal mine present in that same area. So basically that is data mining. What we do is we identify the pattern or the correlation between those say different data sets to find, or we correlate these different data sets with the large data sets. What is data profiling is that we analyze uh, these data from existing database or existing data sets. So say what we do is there are particular mines present in a particular area. So what we do is we analyze those mines, we actually send workers into those mines, then those workers bring up some materials, and then we examine them, and then we classify them into particular minerals, say coal, gold, or petroleum, etc. So basically data profiling, what does data profiling do is it analyzes the data from existing data sets to determine the actual contents. Data mining is applying computer-based methodologies and mathematical algorithms, and data profiling is analyzing raw data from existing data sets. Data mining is we mine data for actionable information. That means that, say, if I have a particular data set, if I have been given a particular data set, and if I want to perform some certain mathematical actions or mathematical algorithms on, say, out of 10, I want to perform those mathematical algorithms on 5 data sets. So what I do is I mine those 5 data from that given data set, and I perform some particular actions of information on those data. And what data profiling is that I create a knowledge base of accurate information. I go through those database and I create data sets and I create a base so that all these data sets or all these data present in that particular data set actually makes sense or actually has some meaning to it. In data mining, there the classification is as a clustering or regression. In data profiling, the set of activities includes discoveries and analytical techniques. So moving to our final question, in which I've been given problem statement, in which I have to check if the words in the given string are even, then all for all those even words, I have to print the word even with an exclamation mark. So now let's go to the code. What I did here is I defined a function print words and I gave it a parameter as s. In s, I said that s is equal to s dot split. So what I did is s is my string. I said that I want to split that strings wherever there is a space. So it will only contain words. And I said that I iterate in words of string. So what I did is I ran a for loop, which I said for word in s. So for every word that is present in this s, it will say that if length of that particular word mod 2 is equal to 0. So let's say for COVID it is 5 mod 2 is not equal to 0. So it will go back again for the condition to be satisfied. Then it will check 19. So yes, it is 2. So 2 mod 2 is equal to 0. So then it will print even. So let me run this code. So for every word which is even, it is printing out even. So let's say 19 is even, so it printed out even once. Then 1 2 3 4 5 6 7 8 9 10 11, so it won't print out for this. For cases it won't print out. For r it won't print out. 1 2 3 4 5 6 7 8 9 10. For increasing it prints out an even. For at it prints out an even. For faster, it prints out an even, and for rate, it prints out as even. Now coming to the final part, for the references, I referred this book O'Reilly Second Edition Python for Data Analysis by Wes McKinley, and I would like to thank all the teachers for giving me this opportunity to explain this data analytics topics.